recording. Take a moment to copy this example down, class. I'll be right back, okay? Think about why this integral is improper. Think about why this integral is improper. All right, so let's, yeah, Mark, let's just, after class, if you have a moment, I just have to chat with you real quick, okay? Okay, so what's the problem with this integral? What's the problem with this integral, class?
I think it's because we have a 0, so we will have 0 minus 1, so we get a negative number.
Well, 0's okay, actually. Actually, that's a good, so I appreciate, let's take a look at that. Let's take a look at that. So if your function here is equal to 1 over x minus 1 to the third power, and if you evaluate f of 0, that would be 1 over 0 minus 1 to the third power, which is equal, let me just kind of separate this, which is equal to 1 over negative 1 to the third. But negative 1 to the third is defined. It's an odd root. That's going to give you negative 1. So it's defined at x equals 0. So x equals 0 and x equals 28 are okay. But Susanna's noticing that 1 is between 0 and 28. So your limits, they go from 0 to 28, but x equals 1 is in there. And the problem is the denominator is not defined. The denominator here is not defined at x equals 1. It's not defined there. So that's the problem. So what we have to do, well, how are we going to handle this? What do you think we need to do with this improper integral to handle this issue? It's a type 2 improper integral. That's right, Jonathan, if there were an infinity in where that 28 is, then that would be an extra complication. We're going to try to keep our problems fairly straightforward here. But yeah, it can happen. But I think for the homework, your improper integrals are either going to be type 1 or type 2. This is a type 2. What do you think we can do with this integral to handle this problem? The fact that at x equals 1, there's going to be an asymptote. Well, indeed, we're going to be making a substitution. But is there anything we can do to the integral that might be good?
Split it between 0 and 1 and then 1 and 28.
That's right, Shalom. Split it. Very good. Split the integral up. That's what we're going to do. So Here I split it up. I split the integral up. I write the integral from 0 to 28 as the sum of two integrals. The first integral goes from 0 to 1, and I guess I can make this maybe look a little nicer here. Zero to 1, plus the integral from 1 to 28. And I'll call those integrals I sub 1 and I sub 2. So that's how you have to do this kind of problem. That's how you have to do this kind of problem. So what we'll do is we'll try to see if the first integral, I sub 1, converges. So, all right, well, now, I sub 1, of course, you know, your integral goes from 0 to 1. And you are approaching 1. You have to be, so of course the 1 is where the problem is. So I'm going to replace the 1 with a t. But then how am I approaching 1? I'm approaching 1 from the left. And so t approaches 1 from the left. So we'll let u equal x minus 1. Then du equals dx, of course. Okay, and so now we get this integral with respect to u. The t becomes a t minus 1. And the 0, the x limit of 0 becomes negative 1 because u equals x minus 1 and 0 minus 1 equals negative 1. And then 1 over u to the 1/3 is u to the negative 1/3. So that gets us down to this step here. Please let me know if you have any questions. Susanna, yes.
Why is it important that we know whether it's coming from the left or the right? If we get that wrong, is that going to affect our...
It won't. It won't. It's just, you know, proper math notation.
Okay.
That's really what it is.
Okay, cool.
All right, very good. Oh, Jonathan says, all right, so for here, good question. So u equals x minus 1. If u equals x minus 1, du dx would just equal 1, right? So du equals dx. So hopefully, Jonathan, that clarifies that. Okay, and the antiderivative of u to the negative 1/3. Okay, well, u to the negative 1/3. I add 1. And so I'm going to get
Professor?
u. Yes, hold on one moment. U to the 2/3 over 2/3. And so I get 3/2 times u to the 2/3. And that's how I get my, this is 3/2 times u to the 2/3. That's how I get my antiderivative here. Question. Question.
Yes. So my question was, how do we know which number B or like the B or A in the interval do we put for the in the limit?
Well, our function here was, I mean, this is our function, 1 divided by x minus 1 to the third power. And so
Yeah.
that function is not defined at x equals 1. So that's how I know to split the integral up along x equals 1. If I had x minus 2 to the third power, I would split the integral on the bottom. I would split the integral up along x equals 2.
No, Professor, I'm
Oh,
saying
you're okay
when
with
we
that? Oh, okay.
yeah, when we say about the limit t goes to 1, how do we know that t goes to 1? Like, how do we know which?
Which direction? From the left to the
No,
right?
no, I mean, how do we know that the limit t goes to 1? You know, how do we know that it goes to 1 and not another number?
Because here, like for integral 1, this is the improper integral, right?
Mm-hmm.
And I'm replacing the 1 there with a t, right?
Yes.
Well, and so if I take the limit of the integral as t approaches a number, wouldn't it have to approach 1?
Yeah.
Because the top limit is 1. But you
Mm-hmm.
see, we can't do an integral where the top limit is 1 because the denominator is undefined at x equals 1. So what I do is I say, okay, well, let me replace the top limit with a t value. T won't equal 1, but I will study the limit of the integral as t approaches 1. You see? And so that allows me to study this improper integral. Okay? Is that all right?
Yeah.
Okay. Okay. Some very good questions here. So, okay, well, now we're down to here. Now we're down to here. And I'm going to go ahead and evaluate this integral. So well, I'm gonna put in my values of t minus 1 and negative 1 first, and then I'll compute the limit. So if we go to the next page, this is what we'll have. And by the way, what I'm gonna do, yeah, there's okay, good. So the 3 halves, of course, the 3 halves here, I'll bring that out in front of the limit, right? So if I bring that out in front of the limit, that's going to get me 3 halves. So one of our students needs to mute their mic. Okay. Thank you. All right. And then right, this is what we're doing. So the 3 halves gets brought out in front of the limit. And so this is what we have. And so are there any questions on that? Okay, then we go to the next page. We substitute in the t minus 1 and the negative 1. And then when we take the limit this would just be 3/2 times 1 minus 1 to the 2/3 power minus 1. Which is 0 to the 2/3. And that is going to equal negative 3/2. So the first integral converged. First integral converged. And this means then that now we have to pursue the second integral to see if that integral converges. Makes sense, right? All right, and so we'll move to the next page, but I want to make sure everybody's comfortable before we move forward. Okay. Okay. Very good, Mandy. All right, well, let's move forward. Now we look at the second integral. And the beauty is, it's really, the process is the same. I mean, you're going to be doing the same u substitution and all that. Now, the limit, the left and right limits are 1 and 28. So if we have a 1 and we have a 28, then we have to be approaching 1 now from the right. And so that's why we have the plus here. We let u equals x minus 1, du equals dx. Yes. Franklin, you mean the previous page? I tell you what, Franklin, do you think we could, can I go back to that page after I'm done? Can I go back to that in a little bit? Is that okay? Okay, all right, let's proceed forward and then I'll go back to that previous page. All right, let me give you a moment to just kind of copy things down here. (27) is 28 minus 1. And then t becomes t minus 1. So we're down to here. Okay, so again, you know, the entire process is basically the same. You know, antiderivative is the same, and you know, t minus 1 to the 2/3 power here. So you know, I think, you know, I don't think I need to kind of word for word detail every step here. Hopefully it's pretty clear, but I'll put in this additional step and then, you know, you're going to get 27 halves. So this second integral also converges. How would we get then the answer then for the integral we're looking for? What do we have to do with these values,
We
two convergent values?
we add them up.
We add them up. That's right, Clea. Add them up. That's right, Jonathan. Yep, absolutely. Are there any questions on the work you're seeing on this page? All right. Well, then we go to the next page then. It's really beautiful stuff. And we add the -3/2, which was the value of our first integral, and the 27/2, which is the value of the second integral. We get 24/2, which is 12. And so our integral converges, and it equals 12. All right. So who's feeling okay with improper integrals so far? Who has, all right, Yonatan's cool with it. And Masume is wonderful. Avery, wonderful. All right, very good. And Franklin, you needed to go back, you said a few pages.
No, Professor, it's okay.
You're good?
Yes.
You're okay. Okay, all right, no problem. And hey, you know, we can get that after the class too, if, you know. All right, very good, very good. Well, now what I want to do, I want to do another problem with you. I want to do another one. Just hold on, let me find it here. Yeah, this is the one. This one I'm going to go to the whiteboard for. Okay, so let me bring up the thing here. One moment. Where is it? Here it is. Okay. Let's do another one. Let's say you have the integral from 0 to 3. Let me do this a little better. Okay, you have the integral from 0 to 3 of 1 over x minus 1 dx. Why is this an improper integral? That's right. That's right, Yonatan. When x equals 1, the denominator is 0. So if we were to graph this function 1 over x minus 1, we would see there would be an asymptote at x equals 1. Okay. Now, what we'll do is we'll split this integral up. What are we going to split the integral up on? What number? First integral goes from 0 to, okay, Yonatan knows, but let's see if we have a few other folks here. First integral goes from 0 to
1.
1. That's right, Clea. And the second integral then would go from 1 to 3. So we'll call this integral 1 plus integral 2. And what we'll do is we'll find integral 1 first. We'll look at that. So integral 1, which is the integral from 0 to 1 of 1 over x minus 1 dx. Okay, well, we'll write that as the limit as from 0 to t, as t approaches 1. Let me see now, from 0 to 1. You see here, 0 to 1. I got to approach 1 from the left. So I'm approaching 1 from the left of 1 over x minus 1 dx. Now, the reason it's an improper integral is because the denominator is not defined at x equals 1. but x equals 1 is between the limits of 0 and 3. It falls inside that domain, so to speak. So it's a problem. It's a problem. Okay? All right. Well, so we need to compute this integral here. What procedure do you want to use?
Substitution.
Substitution. I agree, Shalom. Substitution's good. So what will we let u equal?
X minus 1.
That's right, Clea. Good. So u equals x minus 1, du equals dx. And so now I'm going to write this integral. It's still the limit as t approaches 1 from the left. But my new limits are going to be t minus 1 and negative 1, right? Because the negative 1 is just from 0 minus 1. Okay, 1 over u du. Okay, so what's the antiderivative of 1 over u?
Ln u. So
Natural log, good. The natural log of the absolute value of u. So when I do my limit here, I'm going to have the log of the absolute value of t minus 1 minus the log of the absolute value of negative 1. Now the log of absolute value of negative 1 is the log of positive 1. What's the natural log of 1 equal to? You remember, for the log function, it equals 0. That's right, Masume. That equals 0. And so what you're left with is the limit as t approaches 1 from the left of the natural log of the absolute value of t minus 1. Well, what's t minus 1 approaching as t goes to 1? What's t minus 1 go to? That's right. That's right, Mark. That's right, Jonathan. It goes to 0. So really, what we want to then know is, okay, well, I mean, what's the log of 0? Well, let me see here. Having a little, well, all right. You know, I can graph the log function. It's not a problem. I can graph the log function. I know how it behaves. Here's 1. Here's y equals the natural log of x. Right? So this is 1. Here's 0. What's happening to the log function as x approaches 0? What does the log function go to?
Negative infinity?
That's right. That's right. And so that's right, Clea. So this limit here, since t minus 1 approaches 0, as t approaches 1, this limit is going to have to equal negative infinity. Because the natural log of 0 is negative infinity. And this is divergence. This is an example of divergence. So recall, this was our first integral. We split our integral from 0 to 3 up into the sum of 2 integrals. And the first integral diverged. Are there any questions on that? All right. Well, so now let's go back to our problem here. So first integral diverged. Should we bother computing the second integral? Do we need to evaluate the second integral? That's right. Well, here's the second integral. But the fact that the first integral diverged, would then the sum of the two integrals diverge?
Yes.
It would, even if the second integral converged. Even if the second integral were a finite number, if you add a finite number plus negative infinity, you're still going to get negative infinity. So you don't even bother, you don't even need to do the second integral. You do not need to compute. Do not need to compute. By virtue of the fact that the first little integral there, I sub 1, diverged. So that tells us then, therefore, that our integral from 0 to 3 of 1 over x minus 1 dx, that diverges. That diverges. Okay, so I wanted to do one where an integral diverged, so you could have a little variety. Are there any questions on that?
So just a question, Professor.
Sure.
So in the exams, when we have this like kind of situation, like you say, we don't need to compute the I2, right? So we can just write that we do not need to do it.
That's correct. In this case,
Okay.
yes. If you've shown that the first little integral there diverged, you don't need to do the second one. That's right. Now, if the first integral converges, then you need to compute the second integral, like we did on the previous problem. But if the first one diverges, you know, it's divergent integrals are not very interesting to us, right? It's the convergent improper integrals that are interesting to us. And they're used in applications. Like, for instance, if you wanted to find the mean life of an atom, how many are taking a physics class here? Okay, Helen is, and IB, and Mark, and a number of you, Opiemi. Sure. So, and then this might come up, then later in your careers, but there's a problem in the book that says to find the mean life of an atom, that involves an improper integral. Okay. So, because it has to do with the radioactive decay and of an atom and or of a substance, and that goes on like forever, right? And so, all right, great. Are there any questions on this before I stop the recording?
I have a question. Is being undefined the same as infinity?
Being undefined is not the same as well, an asymptote, like if you have a function that's undefined at a value, there will be an asymptote there. But it doesn't mean that the area equals infinity. I mean, we saw an example where the previous problem, we had an asymptote at x equals 1, and there the area converged. We had finite area. But in this case, we have an asymptote at x equals 1 for the function, 1 over x minus 1, but the integral, the area under the curve was infinite. So it's like, yeah. So it's yeah. Okay, Suzanne?
1 over 0 is just undefined. That's not.
1 over 0 is undefined. Yes.
Okay.
If you type that in Desmos or on your calculator, it won't even, probably give you an error message.
Okay. Thank you.
You're welcome. You're welcome. Okay, let me stop the recording then. All right.